Good morning, everyone. Today in this session, I'm going to discuss about the range, variance, and standard deviation. In the last class, we started descriptive statistics and we also discussed about the measures of dispersion. Here today we are going to discuss about measures of variability. So that is range, variance, and standard deviation. Before going to this variance and standard deviation, let us discuss what is this population and sample. So population is the entire group that you are taking for analysis or prediction. That is the total data set what we are taking. And sample is the subset of the population. That is taking some random samples from the population. And the size of the sample is always less than the total size of the population. And when you see the diagrammatic representation, you see this is the whole population. This is the population and taking some random samples like this. That becomes the sample. And coming to this population and sample, the mean, when we calculate the mean of a population, it is represented by a symbol called as mu, Greek symbol. And then coming to the sample, it is given by the X bar. And coming to variation, the population, when we are calculating variance for population, it is sigma square. This is the representation. And coming to the sample, it is S square. And standard deviation, it is just sigma. And here it is S. And when you when you want to represent the size of the population, it is represented by the capital N. And when you want to represent the size of the sample data, it is going to be represented by the small n. So these are the terminologies we are going to use for calculation of variance and standard deviation. Coming to this measure of dispersion or variability. A measure of variability is one of the descriptive statistics that represents amount of dispersion in a data set. In earlier last session, we discussed measure of central tendency, which we are going to calculate the mean, median, mode. Describes the typical value, whereas this measure of variability defines how far we are away from the data points tend to fall from the center. And there are three ways to find the measure of dispersion. That is range, variance, and standard deviation. These three comes under measures of dispersion. And measures of central tendency comes under this mean, mode, and median. So these are the two things very important in the descriptive statistics. And coming to the first range, range is nothing but the difference between the largest and smallest values in the data set. It is one of the method in measures of dispersion or variability. And this is the formula. Range formula is just simple. Maximum value minus the minimum value. And let me explain you with a simple example. This is a sample data set given. And by seeing this, one can identify the lowest value is 5 and the highest value is 2500. So the range is 2500 minus 5 equal to 2495. This is the way how we are going to find out the range of a given data set. And coming to this variance, variance is one of the measure of dispersion or variability. It gives how the data points varied from the measure of central tendency. And for population variance, finding the variance for the population data is known as the population variance. And already discussed you the terminology, that is population variance is given by sigma square, which is equal to sigma I equal to 1 to n xi minus mu whole square by n. This xi mu is the mean, n is the total population, and x is the given value in the data set. Similarly, sample variance. Finding the variance to the sample data is known as the sample variance, and it is given by the S square and the same representation I equal to 1 to n xi minus x bar whole square. Instead of n whole n, we are going to give n minus 1. So this is the difference. The denominator part differentiates the population variance and the sample variance. See this population variance and see this sample variance. And here there are two important things to remember for variance. That is why the numerator is squared in variance and why we are squaring. If you just observe the formula, we are squaring the numerator part. Why we are squaring this one? Why? Because there is a chance of getting the opposite signs of positive and negative values. Sometimes there is a chance that may cancel each other and it may tends to 0. So in order to avoid this, we are squaring the values and then hence the values will become only the positive. And coming to this sample variance, for population variance, we have given capital N, whereas coming to the sample variance, we have given N minus 1. Why we are giving like this? So sample statistics underestimates the population parameter due to samples. Sample means we are taking some random sample from the population. So there may be increase or decrease in the sample size and it may be biased. That is, it may tilt towards only one side of the data. So in order to reduce this bias, in estimating the population variance, we use N minus 1 in denominator. Coming to standard deviation denotes how the data point deviates from the measure of central tendency. So it is how the data points deviates from the measure of central tendency, and the square root of variance is nothing but the standard deviation. Whatever the variance we find, if you simply give the square root of variance, that is equal to the standard deviation. And finding the standard deviation for population data is known as population standard deviation. And finding the standard deviation for sample data is known as the sample standard deviation. And these are the formula. How we are going to find out the population standard deviation is sigma. The same formula, just remember what we have given for variance. The only thing is we have given square root of the variance of population deviation. And here also the representation is S equal to square root of variance of sample variance. And let me explain you how we are going to find out the variance and standard deviation of a given particular set. Here, just see the example. If a die is rolled, then find the variance and standard deviation of the possibilities. Let us see what is the solution. See, when a die is rolled, we know that the possible number of outcomes is 6. That is 1 to 6. So the sample space is given by n equal to 6. And the data set is 1, 2, 3, 4, 5, 6. Why? Because it will number from 1 to 6. That is, we have 6 outcomes. So to find the variance, first we need to calculate the mean of the data sets. So the very first point finding out the variance is we are going to find out the mean of the data set. That is x bar. The mean is represented by x bar is equal to the values 1 plus 2 plus 3 plus 4 plus 5. Okay? And then what is n value? 6. So the mean is 3.5. Now we can put the value of data and mean in the formula to get. That is xi minus x bar. What is this xi? Xi is this one, 1. So 1 minus 3.5, which is equal to minus 2.5. That if you do whole square, we are going to get this formula. Similarly, 2 minus 3.5, the given value square. Like that, all terms we are going to find out the square. We are going to square each of the term and that divided by n. So this whole thing, now sigma square is given by, when you calculate all these things, the result is 2.917. Therefore, the variance is 2.917 and standard deviation is square root of the variance, which is 1.708. So this is how we are going to find out the variance and standard deviation of a given whole population or a sample population. Let us discuss one more example. Here, find the standard deviation of the average temperatures recorded over a 5-day period last winter. So these are the temperatures recorded. And let us find out the standard deviation and same the variance. Now, the very first step in finding out the standard deviation or variation is we have to calculate the mean. So the mean is adding all these together and that is 96. How many values we have? N is 5. So it is 19.2. So the mean is 19.22. So in a table, I am representing all these values. That is temperature. And temperature minus mean is equal to deviation. That is 18 minus the mean is 19.2. That is 1.2. And deviation square. That is if you take this as x, then it is x square. So Now 22 minus 19.2, it is 2.8. And if you square 2.8, this is the result. Likewise, all 5 temperature values with minus mean, the deviation and square of all these deviation is this one. And when you sum all these squares, the value is 94.8. Then the next step is, we are going to find the variance. What we are going to do? We are going to divide 5 minus 1. Why? Because this is total population. But when we are finding the sample population, it is n minus 1. So that is 5 minus 1, it is 4. So it is 94.8. The previous one, what we got this value. And by 4 is 23.7. This is the variance. Now from this variance, if you find the square root of this variance, the result will be the standard deviation. So the standard deviation for the temperatures recorded is 4.9 and the variance is 23.7. And finally, if we square root of this variance, we are going to get the same as 4.9. So the answer for this one is standard deviation for the temperatures recorded is 4.9 and variance is 23.7. This is how we are going to find out the variance. That is, first we need to find out the mean. Then the actual value minus the mean, we are going to get some value and we are going to square that sum value. And that sum is divided by n if it is whole population. If it is a sample population, we are going to divide it by n minus 1. And the result is the variance. And if you do the square root of the result of variance, that will be equal to the standard deviation. And these are just practice question. Find the mean and standard deviation of the following set. So start doing this example and see which of these is the correct answer for this given sample data. This is one question. And the second one is, what is the sample standard deviation of all the months in a year that has 31 days? In a year, in 365 days, we have how many months? We have 31 days. So those will be the sample data set. We have 4 or 5. Calculate, and for that find out the sample standard deviation and check what is the answer in this. These are the 2 practice questions. Thank you.